well say New Zealand's just part of Australia. Okay. I joke. Right, welcome back everybody. For those who are wondering what we were just doing, logging a little bit late, well, if you get in early before the modules, you're a chance to win a prize with just some random trivia that Kathy digs up and finds. Always entertaining, so worth logging in 3 minutes early or so just to see what questions will come up. Welcome back. And thanks for your input last module. Yes, Kathy and I were discussing afterwards and saying another wonderful group of people who are excited to interact, which we absolutely love. So please keep chatting through the chat function or the Q&A if you're having trouble with the chat function. And there's a number of things that'll happen in this module, in this session, where you'll be asked to write a few things in. So get ready for that. Kathy, any administrative things to cover off before I jump into a few slides to kick us off?
Thanks, Ken. No, another big shout out to New Zealanders who have all jumped into Moodle and done their quiz. So thanks very much. You guys are fantastic. Really appreciate your efforts there. And yeah, no, everyone seems to be tracking along okay. So great work.
Awesome. We've
got a couple of questions that did come in right at the end of the last session, Ken, which we might get to those ones today, do you think?
One of them associated with motorcycle safety, it will be next session, next module. Okay. So next module, we really focus on vulnerable road users, pedestrians, cyclists, motorcyclists, delve into that a bit. So I'll push that one over. Yep. And you'll have to remind me of the other ones. We did talk about this, but yeah, coffee is still kicking in. But we do cover a fair bit of stuff in this module associated with the roads and the roadside. So,
oh, good.
Yeah. All right. Well, jump back in, Kathy, when the questions come in. But let me cover this one off. So, objectives of this module. We want to get you to be able to estimate kinetic energy thresholds for different crash types at intersections. We already started discussing that, but we're going to delve into it in a bit more detail. We want to identify characteristics of intersection that align highly with safe system principles and characteristics of mid-blocks, which is basically the area between intersections and the alignment, what aligns highly with safe system principles. At mid-block locations, I'm going to spend most of the time on intersections. They're more complex and yeah, there's a lot to do, but certainly the mid-block we will touch on at the end. Don't forget to count your wallies. One thing I wanted to do was give you a little bit of context around safe system assessments. I suppose it was something that there's a little bit of discussion about trying to get people's head around this, because a lot of people have heard of road safety audits. Some of you probably are road safety auditors and have done the maybe safe system engineering workshop that is offered in New Zealand, the week-long thing that I think they sometimes call it Hell Week. It's an intense week there, and you get a bit of a focus on becoming a road safety auditor through that. And road safety audits are a wonderful tool. They are different to a safe system assessment, but there is a bit of overlap. Now, there's a design review, and that's just your process of if you come up with a design, you're designing new infrastructure, you hand it over to somebody else, a fresh set of eyes to look at it, to check the design makes sense, but also, check your calculations on things like drainage or whatever, you've had to calculate, that independent check. It's often done by someone within your team or the like, but there's a design review, and there's some overlap in an audit and a design review, absolutely, and there's stuff outside of a road safety audit the design review does. Now, a safe system assessment, as I say, has overlapping elements, but certainly has a fair bit of stuff that is unique And it's either unique in the way it's presented, the information is presented, or it's looking at different aspects of the project through different lenses. So yeah, there's a little bit of context there. And I mean, they do overlap, but I do often hear people say, we don't need to do a safe system assessment. We're going to do a road safety audit. So that's good. I mean, a safe system assessment doesn't replace road safety audits. Yes, there is significant overlap, but a safe system assessment early on in a project really just helps set a lovely platform then to do supplementary road safety audits along the way. Another one that's a little bit confused, people get a little bit confused by it. It's a term used in some jurisdictions, and to be honest, I'm not sure if New Zealand uses this as a specific term, but safety and design is a term that is more associated with can the new infrastructure be built safely? Can it be decommissioned at the end of its life safely? Can it be maintained safely? And can it be operated safely? So it's a bit more workplace health and safety related. And there's a bit of overlap there with all of this, but there's a lot of other things out there that you're probably not going to cover off in any of those other checks. And then there's a Disability Discrimination Act, the check that can it be used by people of all abilities, people in wheelchairs, vision impaired people, can they use this new infrastructure that you're planning? So, you know, there's a lot of these sort of independent checks within a transport project. And obviously for your big multi-million dollar or multi-billion dollar projects, you're going to be doing all of them. But maybe for very small projects, there'll only be some of these done. Well, we'll come back to that in our last module. Let's talk a little bit about how safe system assessments are playing out in policy, in process. But I wanted to give that context now, just to put us all on the same page. And I think you'll actually get quite excited by some of the things that sit out here that aren't done in a road safety audit or another exercise. Kathy, I'll pause there because I sort of threw that in to give some context before jumping into the content of today, and I'll see if there's any questions around that.
Yeah, there is a question about, is it acceptable to do in-house road safety audits?
Yes, a wonderful question, and I'm currently I'm working on the update to the Austroads Guide to Road Safety Part 6, which is road safety audit. So I was appointed by Austroads as the technical advisor on that, working with Paul Hillier and Joseph Lee on that document. And we're trying to clarify a little bit of that independence in a road safety audit and strengthen a few parts of it. The answer is, if you can prove your independence and that you're not being influenced by anything else, you don't have a conflict of interest on the project, then it's okay. Now, I personally have no worries about transport agency staff doing road safety audits on transport agency projects or local government on local government projects, as long as the audit team is not part of the design team or the project management team or the like. So another area, very separate from it. I think that's all fine. I think where we sort of delve into some potential concerns is when the design company, the company engaged to do the design, the consultancy engaged to do the design, also does the road safety audit. Now, I think most of the time we'll be fine because the engineers, the road safety auditors and the like are very, they have good integrity and they're going to, look at this. They're going to, guarantee they're independent in terms of ensuring they haven't had involvement in that. But it does sort of present you with some potential challenges associated with the inner workings, the time pressures, the cost pressures, the clients needing things and not wanting to spend more money. And there is just an environment there that could slightly compromise the output. So my sort of general take on that as a road authority would be to, require a completely independent design and road safety audit company. And it should be no dramas at all there. That the design, multinational design company or the local design company just engages a completely separate auditor, or the road authority engages the designers and then engages a separate auditor.
Thank you, Ken. Just one more question. At what stage of the project do you do a safe system assessment?
Excellent question. And we do spend a lot of time in the final module delving into this, where it's best done, where you get the best value. But early in the project, when you've got some concepts on the table, is a great time to do it. Just conceptual level stuff. And I promise you this one will get a lot more detail in module 6, the last module. So I will come back to that. Let's talk about intersections. I want to get into an exercise nice and early on a Friday morning. So let me just jump through a couple of slides, and then we'll get you doing a little bit of thinking. The intersection's obviously a challenging spot on our network. The risk spikes. Don't get like mid-block. There is definitely risk throughout. The risk spikes at intersections. Spikes in a number of ways. It spikes obviously with the conflict vehicle to vehicle. It's also the point we have pedestrians crossing often, and we've got cyclists, motorcyclists, everybody, and there's all that conflict points and the like. There's also things that we may not traditionally think of as risk at intersections. Run-off road risk actually goes up at intersections because of a lot of fixed hazards usually around intersections. And also because of that conflict, that turbulence at that point means that people will be avoiding crashes and sometimes leave the road. There'll also be secondary crashes where they might clip a car at an intersection and spin off the road. So intersection crashes aren't just about that. They're about a whole series of crash types, and we'll delve into that. I've taken this information here from Monash University Accident Research Centre in a 3-series investigation into safer intersections that they did, and some really sort of simple principles that they put down about safe system intersection design. The top of their list, they're talking about fewer vehicles. And somebody did ask last week, which we didn't get to, when we talked about exposure, likelihood, and severity, is there a sort of hierarchy on those? Is there one that's better than the other to do? I'm cautious of saying yes, but exposure is, a really effective one if we can reduce vehicles or people through a point. Obviously, if we're moving them to a more dangerous or to another point, we're just sort of moving the problem kicking the problem down the road. But that's a really effective one. Likelihood, hugely important, and severity, hugely important. So I sort of purposely put them as a block rather than a pyramid or anything like that, due to all of them being particularly important. I think you'll find shortly, though, that to achieve safe system outcomes, well, we're going to have to make one of those, either exposure, likelihood, or severity, hugely effective. Ideally, we will make multiple ones effective, but you'll see shortly that we need to make one of those hugely effective to achieve our safe system outcomes. Basically, to put that simply, if you have nobody exposed to a crash, then you're going to get safe system outcomes. If you have no likelihood of crashes, as in nobody will ever crash there, then you're going to get safe system outcomes. And if you have very, very survivable forces, severity of any incident that occurs, you're going to achieve safe system outcomes. Yes, you'll have crashes, but they won't involve death and serious injury, which is our safe system aspiration. But we'll come back to that. So they've gone fewer vehicles, fewer intersections, trying to address the exposure aspects. That's often very hard for us to do, but it does lend us to thinking about closing off access points and intersections, moving transport modes into safer modes. At point 3 there, we get to starting to talk about fewer conflict points per intersection, trying to reduce the number of conflict points. And number 4 here, there is the impact speeds and angles. Speeds and angles. And now we're into the severity. And it's all about biomechanically tolerable levels. Biomechanical limits are, the forces that your body can handle or anybody's body can handle. And we talked about this last week. For 90-degree collisions between passenger vehicles, we're talking around the 50 kilometers per hour. Where you can get more angle on that, we can increase the speeds within our tolerable levels. And this goes back to your sort of year 11 vectors in physics, doesn't it? So if you can get a bit of angle like that on a crash, the energy is sort of pushed out into the environment. You sort of bounce off, don't you? The energy is not transferred straight into the other. If it's a right angle, it's transferred, directly in. So if you can get more angle on your crash, you're in a better position in terms of biomechanically tolerable limits. Also, if you can get it to be more of a head-on crash, you actually find yourself in a better position. And that's due to engaging some of those wonderful features of passenger vehicles, some of those safety features being the crumple zone, airbag, seatbelt. They're all a frontal crash severity reducing factor. And the side of the vehicle is really not good. Not good for crash impact, absorbing energy and the like, or stopping it transferring to the human. Even with side curtain airbags and the like, we're not great at that. But you can get it up to sort of between 50 and 70 in terms of getting these better angles on these crashes within our tolerable limits. Now, I'm not saying that we want these crashes to happen and we should do everything to minimize the likelihood, but we've got to get our mind in this place where we believe it is going to happen, and how do we manage the energy? Where we have vulnerable road users, we're looking at nothing above the 30 kilometer per hour mark. And if you can't sort of achieve these, we've got to re-look at that intersection and try to minimize risk as much as possible. So just some generic principles there. Lots to talk about on each of those, and I'm sure you've got lots to mention. But we'll play that out in a practical exercise. I think it's always one of the easiest ways to do it. But here's a table to try to summarize that. This is passenger vehicle crashes. Generally, around the 40, we're accepting that within biomechanical tolerance levels. 50 around the 90. 60 kilometer per hour, we're talking about these other angles. And this is from ChemX, which is the kinetic energy management model. And it's a very it's an in-depth tool to analyze the forces around crashes at intersections. Now, in a safe system assessment, you do not need to go to that detail, right? You take these sort of broad brush levels and you make an informed call on the severity of crashes. You don't analyze in this much precision. You could. It would make your safe system assessments, multi-month exercises, which is really not the point of them. They're there to give these general broad brush indications of where the project or the design is in terms of alignment with safe system principles. 70 kilometers per hour for our rear end and head-on style crashes. Rear end, you could probably get a little bit more if you've got, if you're imagining some movement there of the vehicle. and really nothing for an 80 kilometre per hour change in speed, right? This is a delta V we're talking about, change in velocity, okay? So you can operate an intersection above 80 kilometres an hour if you have a lower change in speed. And you know, the simple one we're talking about here is an acceleration lane. Okay, so you can have this one at 100 and this one at 120 kilometers an hour, and everything's aligning fine with our safe system principles for the initial crash. You would have to obviously be thinking about what they're going to leave the road and hit or the like, but that initial crash force is within tolerable limits because the delta V is 20. So you can, you know, very roughly, and you don't need to be this precise, you can sort of say, oh, okay, they're planning a new intersection here, you know, vehicle's going to come out, oh, that's pretty close to a right angle crash, so that's about 50. I should use something other than red for this one. That's about 50. Okay, that one they can probably go a bit faster, probably around 60 kilometers an hour on that one because they're getting more angle on that crash when it happens. And you're starting to, you know, relate geometry of the intersection and the angles of conflict points back to some speeds, some desirable speeds, some threshold speeds. And I did mention there that secondary crash, and it's, I think, often forgotten within intersections. Everybody's focused on that initial crash, which obviously is very important. But thinking about this secondary crash, and it might be, you know, very clean like this one, and then the obviously resulting force is out that way, as you can see there. But it might be that this vehicle actually, you know, clips the front, spins off, clips the back, spins off. You know, it shunts this car slightly and they go flying off. All sorts of things can happen at these intersections. And so we need to sort of think about the placement of rigid hazards around intersections and remember that our run-off road risk spikes a little bit. Here's a bit of research from the Centre for Automotive Safety Research in the University of Adelaide, which has sort of reconstructed lots of crashes between passenger vehicles, put them onto one axis, so the point in the middle there being the intersection, and shown you where the secondary crashes occur. Pretty obvious, I mean, that they're going to occur out here. You do get the sort of, as I talked about, spin-off ones or random, you know, bits and pieces, but, you know, predominantly going to secondary crash out there. So just keep that in mind as well. Remember to always think back to your conflict angle, relate that to speed. This is passenger vehicles, remember? So I'm going to introduce you to a little exercise now after that very, very brief introduction. We'll talk a lot more about intersections after, but I want you to do a little bit of thinking now. But before I do that, I'll check if there's any questions at this point, Kathy.
We are good, Ken. Carry on.
Right. I'm going to introduce you to a little intersection, and your job's going to be to redesign it. And nothing like redesigning an intersection on a Friday morning gets you excited for the weekend. So here we go. Nice intersection. Two carriageways there on the main road. The main road here are carrying 20,000 vehicles a day at 14% CV, 14% commercial vehicles, trucks, 20,000 vehicles a day. So pumping a lot of traffic along there. And the side road here is much lower, and it's got 1,800 vehicles a day. So, you know, it's got a bit. And down here is a school, right? About 400 meters down there's a school. What do we got here? We've got, this is a shared path, pedestrians, cyclists. This is like a drainage structure. This is sort of like where it's sort of a little bit of a floodplain area. The water obviously comes in there and out it goes. These are service roads, multi-directional service roads, both there. You obviously got a turn lane. This is a bus stop here. Okay. Bus stop. This is a bus route. What else can I tell you about this? This is a little Danish offset crossing. Danish offset, or Z crossing, as people will often call it. Just that one where you walk into the median and then you walk along, and then this is the wrong way around. You would want usually your Danish offsets to go the other way, so you're walking always at traffic, or your pedestrians are walking at traffic anytime they cross. But that's a little minor aside. That's what I pick up in a road safety audit. I might pick it up in a safe system assessment as well, but it's tiny little alteration in the likelihood of crashes. Residential. Let's have a look at it from, I better tell you the speed limits. 70 on this road, default 50 km/h on this road. Here it is at ground level. So you can see there's the bus stop over there. You can see the service road there. See the turn lane, 2 lanes in each direction. Have a look at it from the other side. Looking back, there's that drainage structure thing. There's a shared path out here. Okay, nice little intersection to work with. What your task is to redesign this intersection and also do any other activities that you would like to eliminate death and serious injury at this intersection going forward, or get us as close to elimination as we possibly can. Okay. Now, I am going to put a few little constraints on you. Can't make it too easy. I'm going to bring it back a little more real world for us. I'm going to give you a budget. Now, because you're a nice group, I'm going to give you $2.7 million. 2.7. Oh, 2.7 million. That's your budget. The next constraint I'm going to give you is that we've done a lot of consultation in this area with the residents, the school, a whole lot of people. And we've established that we must keep access to this intersection open in both directions. So people have to be able to turn in from both directions and turn out from both directions, turn out and go both directions. So I know you were thinking back to that first slide I put up and thinking, oh, could I just close this? That would be a very wonderful, wonderfully aligned, safe system way to approach this. Unfortunately, you can't do that. So that's just one that's off the table. You have to keep this open. That isn't necessarily keep the service roads open, but that's just probably a more minor thing, isn't it? The final constraint you have is that you are operating within the current political and organizational climate that you currently operate. So, maybe you've got a wonderful idea, but it's it's never been done before and it's very controversial and the like. You can put it forward, but I want a little bit of a plan or some ideas on how you might get that through and approved in your organization, but also get that accepted by the community and any political, politicians or the like that it would be involved in any infrastructure decisions or would be commenting on any infrastructure that's going in their area. Okay, so 2.7 million. I've got to keep it open. And you've got to get it through your current political, organizational, community desires, or what their level of expectation is, or alter their levels of expectation and the like. So, any questions on your task? Any questions about the intersection itself?
I think we'll just give people a moment to
The
ask
one
questions.
The one thing I haven't mentioned in the task is that when you come up with ideas, we want you to type them in, but we also want you to type in whether what you're planning or what your idea is alters the exposure or the likelihood or the severity or a combination. So I don't know, maybe you say, I'm going to do a big grade separation, a big flyover, so a big flyover here and a big entry lane, and this, road's going to go over the top with a big structure. Obviously, you're not going to do this within 2.7 million, but if you say that, then you might say, I'm going to alter the exposure to crashes because I'm, removing conflict points or something like that. You say big flyover exposure. The other thing is that I accept that some of you probably are not cost estimators. You're not sure how much these things might cost. So what I'm going to do is provide you the instant cost estimator service. So you can simply type in what you're thinking about, and I will tell you a cost straight away back of that at this intersection. The flyover I mentioned, full grade separation, full flyover is going to cost $36.2 million. We're going to buy quite a few houses and a massive structure, 36 million. So over to you. Let's go. Let's do it. Remember to put in exposure, likelihood, severity.
Okay, so we have some questions. Do the service lanes have other entry points that will enable us to close them at this location?
Well, they do have other entry points up and down. You're probably going to need to think about how things like the rubbish truck will turn around and the like. But yeah, there's other entry points, so that's not an issue. I suppose having a think about those is good. If we fix the service roads and the service road entry, is that going to eliminate death and serious injury at this intersection? Leave that to you to decide.
And could you tell us how much a roundabout would cost?
Oh, yeah. Okay. So a roundabout to meet the Off-Roads Guide to Road Design Part 4A, is it 4A's roundabouts, I think, is going to cost you $5.8 million. It's outside your budget due to the size of it. It's moving services, land acquisition, moving that drain. And the reason is because this is a heavy vehicle road, takes a lot of larger vehicles, and in order to get them around, that is the requirement. Out of budget for a full-sized roundabout.
I don't know if you heard that, Ken. There was a collective groan as everyone's idea, you ripped it out of them. Anyway, can you?
It's the world we live in.
It is.
Infrastructure ain't cheap.
Could you tell us how much for a Seagull with a shared path underpass?
Signalised Seagull or non-signalised Seagull? I'll give both.
Okay.
A non-signalised Seagull intersection with a, what was it?
A shared path underpass.
Right. Okay. That is going to be $3 million. The shared path underpass is where your big expense is. The Seagull on its own is $750,000. It's the big getting that underpass dug is where you're going to blow your budget. The signalised Seagull goes up to 1.9 million for a signalised Seagull. Yeah.
Thanks, Ken. You've been told that your roundabout prices are a rip-off. Apparently 700K for a roundabout in the Southland. Anyway,
On a local road, I would imagine,
all right.
or not a national highway. This is like roundabout State Highway 1 sort of stuff.
Could you give us, let's see how far your cost estimation can go. How much to have a police officer stationed there 24/7?
Yeah, okay. This is innovative thinking. I'm liking this. It is 270,000 a year.
Okay, great. Could you also just give us a brief, what is a seagull?
Yeah, good question. I'll come back to that.
Okay, all right.
Somebody's pondering seagulls.
Yeah, okay, all right. Sorry, there's a lot of, this is, as you say, New Zealanders are my favourite because they're so active. Could you tell us how much for a raised intersection and signals?
Yep. Okay, raised intersection and signals is 2.4 million.
Money left over.
Good Christmas party if you were going down that approach.
Okay. Cost of safety cameras, please.
Safety cameras are 500,000 for speed and red light. If you put signals, or just speed if you don't have signals there, and they're about the same, 500,000 either way.
I think you might have covered this one. Any issue if we change this service lane to a one-way lane?
No. So you've got ways to get them out and get them in. No issues there.
How much for a grade-separated pedestrian cycle facility?
Yeah, okay. 2.9, but I know a guy. And
a New Zealander?
New Zealander. And we can get the construction done for 2.7 because because it's all about safety. 2.7.
Sounds like you're getting some kickbacks. Anyway, did you say that we can't restrict movement, for example, one way in, one way out?
Yeah, no, that's right. Unless you had some way to get them to go the other way very much within the sort of general envelope of this intersection. No, we can't be driving them a kilometre down the road to do a U-turn. That's certainly been pushed back and taken off the table. But I do like the thinking of whoever's thinking that way.
All right, I think I've got all the questions out. There's plenty of people popping in some responses already. If I haven't asked your cost estimation.
Sorry, there's more cost estimation to do?
I
like my cost estimation service.
It's a bit random. No, we might. I think we might give people a few minutes to have a think. Gone through lots of.
What I'm liking seeing already that's coming in is that when people are saying their idea, they're saying whether it's influencing the exposure, the likelihood, or the severity. So please keep doing that.
Yeah. Okay. Great. I think we're good. So maybe we'll just give everyone a couple of minutes now.
Yeah.
Beautiful.
So if you've popped it in, have a stretch and fill up your water. If not, just keep typing it in there. I'm seeing some wonderful stuff coming in. So I've just seen David's comment. Cost of a consultant to tell the ratepayers it's a perceived issue, not a real issue. I'm not sure if he's saying it's a perceived issue, as in the intersection or his infrastructure will do something. But I'm going to say $100,000 for a comms and engagement campaign there with all the bells and whistles. This is great. Just the amount of ideas coming in here. And thinking outside the square, I see. Oh my gosh, this is great coming in. Remember to put exposure, likelihood, or severity there. Make sure any ideas come along with that, and that's a really important thing to be thinking about that. I'm not on mute, whoever's asked that. I may be lagging a little bit. Sorry. Maybe you just reply to Simon K there, Kathy, and just say that I'm not on mute. Kathy is on mute. All right. I'm just loving this. This is great. I'm going to start going through some of these. Oh my gosh. It's just an absolute plethora of them, and they are brilliant. Okay. Here I go. So, a little bit of commentary around crash types, and I didn't even talk about crash types. And actually, interestingly, I don't do a lot of crash analysis anymore. I mean, I used to do a lot of crash analysis. These days, safe system assessments aren't about reactive crash analysis. It may give you some insights, but just because there haven't been a certain crash there doesn't mean there's not a risk there. It just may not have presented in a crash yet. Crash, if you do have like a very distinct pattern of certain crash types, that's obviously an indicator of future risk. But yeah, just thinking about the energy and chance involved. Don't get fixated on crashes, is what I'd say. Use them to gather intel, to get information. But the one thing that, I would certainly be very upset if you came out of this course and with any sort of impression that if an intersection like this had 0 crashes at it in the past 5 years, that it was aligned with safe system principles. Absolutely not. Right? That is definitely not the case. But you might get some intel from the patterns of crashes the road users involved. There has been a crash history at this intersection, and it's all been vehicle-to-vehicle crashes, no pedestrians, no cyclists involved. Oh, sorry, there was one motorcyclist, a vulnerable road user involved, but it's been vehicles coming out, being struck by vehicles going through, and vehicles turning in, being struck by vehicles going through. That's been all the crashes, and there was a couple of minor crashes that way. Anyway, so what we've got here, we've got a number of people looked at roundabouts and then dismissed them. And then we had people talking about signalisation of the intersection. And I think we're all aware of what signalisation is, so I don't need to draw that. There was that discussion about seagulls. Now, a seagull, for those who aren't aware, is basically where you put a sort of, so you've got a turn in there, and then it's got essentially an acceleration lane off the right. So you come in here and you accelerate down. So that's a seagull. If you sort of turn it on, it's like kind of looks like a seagull. I think that's why it's called that. Now, I can't find it immediately, whoever said seagull, whether they put that into exposure, likelihood, or severity. But let me tell you, a seagull intersection is it's a very interesting intersection type for a number of reasons. So the severity of a crash will be reduced at this conflict point because you've got a better angle, right? No change here, no change here for these crashes. That's the same conflict angle as it was before, and it's not a great conflict angle. The likelihood of crashes at seagull intersections generally goes up. The reason for that is that this move is a very hard thing to do. Merge from the right. It's very hard for a lot of road users to be able to head check at that angle. They will just utilize mirrors in order to do it because that head check's too hard. There's often not enough acceleration room. You have to go a long way to get up to proper speed there. And of course, articulated vehicles like a truck with a cabin, they cannot look through that cabin. Whatever's behind them, they're big trucks, so they're really just relying on them. We do have a lot of problems with crashes at seagull intersections at this location. So that's a challenge there. Interestingly, a New Zealander has done probably some of the world's best work on seagull intersections in terms of analysing the characteristics of seagulls that are good, that are bad, and actually produced a tool for Waka Kotahi that helps you decide whether a seagull will perform decently with all the flow and the speed and the different characteristics. So that was Shane Turner, for those who know Shane. He's produced that, and it's available on Waka Kotahi website. And I can send it to anybody. It's actually a Excel-based seagull intersection analysis tool and a report that goes with it. So we'll probably get some severity improvements there, but I think it might be outweighed by some likelihood issues. But nonetheless, great one to look at. And thank you. Okay. So let's go back and look at what other ideas we had. Oh my gosh, so many great ideas here. And I think I'm definitely not going to get through everybody's ideas, so I apologize in advance. We'll have a look at them. So I'm just moving through. Okay. So we've got some people putting signalisation, and they're rightly saying, and I'm seeing it multiple times here, that will influence the likelihood of crashes. Yes, if we signalise this intersection, we are going to reduce the likelihood of serious crashes occurring because we're telling people when they can go and when not to go. We're stopping vehicles for other vehicles to come in and come out. We're not addressing the severity of crashes, though, with the signalised intersection, nor the exposure of crashes. Now, you'd need some traffic modelling to tell you, precisely what it does to exposure. It might increase, more people might access through there. That's okay. We don't need to get too worried about those intricate details. We've got some people then saying, how about we do a raised platform or raise this intersection, sometimes with signals, and that will slow vehicles down, and that will influence the severity. Spot on. So the signalisations are going to look after the likelihood, but we've still got that severity issue. So reducing the speed in one way or another is going to reduce the severity as well. Now we're talking there. So this is actually quite an enlightened group to start thinking down that track already. Just looking for some different things. Okay, So we've got people wanting to grade separate the pedestrians and cyclists. Very laudable thing to do. That's a great idea. So maybe a pedestrian overpass, and that will influence the exposure as long as they use it. Now, I have seen in my time a lot of pedestrian overpasses that I would say have been a big waste of money because a lot of people are not using them. And so always remember that, if it's not going to be used, if it's not desirable to use it, they won't use it. They'll just continue to cross at grade, and you've lost the benefits there. But they're using it, and it's reducing the number of pedestrians or cyclists that are exposed to that conflict point, then we reduce the exposure to crashes. Okay, so we've got some people who want to put some barrier systems along here and saying that will reduce the severity of crashes. Spot on. Okay, so the barrier there means that if somebody leaves the road at that point, they can hit the barrier, run along it. They're still involved in a crash, but the severity of that crash is much less, isn't it, than landing in the structure and abruptly stopping. Speed platforms, signals, likelihood, speed platform, severity, moving the bus stop away. I would tend to say, if you move the bus stop, I tend to say that's a likelihood reducer rather than an exposure factor, because the people getting on and off the bus, or the bus and the turbulence that might cause, is still there. I mean, it's still in the general area. So if we put it away from a little bit of the chaos going on here, it's still there. It's just less likely to cause a fatal serious injury. Reduce the speed limit on the local road. Now, will that influence the exposure likelihood or severity? I think you could say that it will reduce the severity and likelihood on the local road crashes, right? Is reducing the speed limit on this road going to do anything for crash severity out on the main road? Probably not, because that's not this one coming out or going in. That's not our bullet vehicle, is it? That's not the one that's going to be doing the damage. Now, if this was a crossroad, maybe we'd have a potential overshoot issue, and then they would have the speed to be a bullet vehicle. But T intersection like this, that's not going to be a bullet vehicle. So realigning the service roads and the like, opening up sight lines, all likelihood issues. Well done. Lots of support for signalisation. So then somebody's popped in there the possibility of utilising the drainage structure as a pedestrian cyclist underpass, influencing the exposure to crashes. I love that idea. Right? I mean, people get really freaked out about this idea. They're like, oh, you're going to do that? What if it's filled with water and we're going to drown the, pedestrians and cyclists? Well, I've got a few examples of where it's been done and done successfully. Yes, you've got a personal safety challenge. People don't like walking through dark tunnels. It can be a little bit scary. You might be able to cut an opening there with appropriate barrier systems, get some light in there and the like. You've got existing infrastructure. It'd be nice. The reality of this one was far too short to be able to do that. But I love the idea and the thinking behind it, because if we can remove the exposure to crashes there, what a wonderful safe system outcome. Sorry, just scrolling to see if there's... Okay. So installing some turn lanes, people are interested in that on the road coming out. That will probably do a little bit to reduce the likelihood of crashes, but not. Oh no, it might do a bit. Open up some sight lines potentially, clarify some of that. Maybe reduce a bit of wait time. So then we had some people looking at the enforcement aspects, and I do like that, thinking outside of just what can we build. Can we, enforce some good behavior here with cameras, reduce the likelihood, potentially a bit the severity as well, because if we're bringing speed down, the severity will reduce as well. And people having ideas that might give us a halo effect, give us a bit of an effect around further. Wow. Okay. Sorry, they're just reading some long answers here, and they're really good. We've seen great stuff come in. I think I've covered quite a bit of it.
And can I just jump in with a couple more that came
Yeah.
through? There's installation of a temporary roundabout and then seek more funding. So get buy-in to begin with.
I like that. That's a really nice way to go. And whoever's said that is obviously somebody who's tried to build a lot of infrastructure in their time and understands the fact that community get freaked out by change, and if you can sort of nice little gentle dip the toe in the water with the community, they can be a little less angry about these changes, and also, and you can activate a community to lobby for stuff. I mean, I certainly used to be my absolute go-to always. We wanted to do something, and I go, and the community pushed back, and we just go, okay, well, we're going to just trial this, and we're going to put some temporary stuff in here, and if it doesn't work, we're going to remove it. And because they can just, they have this vision that it's going to end, be the worst thing in the world, and and then once it's in and it's operating, and they realize, it's like any change. People freak out about change. And then after the change has been there for a while, and then all of a sudden everybody's okay with it. It's like me with online learning, training. I was like, no way. I need to see people. I need to be able to interact with them. I need to see their facial expressions alike. But COVID pushed us into that change, and now I'm okay with it. So, the temporary pop-up style ideas are often a really good one to ease into things. So well done. And so the temporary roundabout, that will reduce the severity of crashes because speeds will go down, and I'll talk about that a bit more in a second. That was a good one. Yep. Other things, Kathy? Anything else?
There was also another one about a comms plan for work. Use school kids, tell their stories, and maybe use them for solutions.
Oh, beautiful. Kids are a great engagement tool. I mean, you can get a lot of change quite easily if it's about protecting the kids. And I'm not against leveraging off that. You have a school in the area and utilizing that to help move your case forward it's just a wonderful idea. How to sell infrastructure, safety infrastructure, getting the kids on board, you're on a winner.
I think that's terrific response. Thank you, everyone. That's really good.
One of the best we've had on this exercise. And actually, interestingly, back when I've used this intersection as an example quite a lot, and I've seen a lot of change over time in how people think about this now, and I think that's just a wonderful thing. New Zealanders traditionally, I would say, think about this in a far more advanced safe system way than say our Queensland friends, who we also present to. They take a bit of time to warm up to some of the ideas that you're naturally talking about. Let's talk a little bit about a few of those things that you came up with, and I'll show you what they ended up doing at that one. And we'll talk about some advantages and disadvantages. So we had some people say signalisation, and I can understand why. I mean, first of all, we established that a full-size roundabout was out of our budget. But also when you have that unbalanced traffic flow, if you have a road with 20,000 on it and then a road with 2,000 on the side road, you have an unbalanced flow, and a roundabout can be a bit challenging with unbalanced flow. So we'll come back to that. But the key there to talk about was that signals influence the likelihood of crashes. They do a pretty good job of that. I mean, we know they have about a 45% crash reduction factor. So we know we're going to reduce crashes by about 45% at that intersection by putting a set of traffic signals there. It does sort of say, and that will be through stopping crashes happening in the first place. So we've got a 55% residual. And interestingly, when you map death and serious injury, so this is just using a heat mapping system. So you plug in your death and serious injury crashes by location and heat map it. And this is, I just randomly picked sort of outer suburban Melbourne, but you could do this for outer suburban Auckland or Christchurch or Wellington or Hamilton. It's going to come out with fairly similar. It always does. But your hotspots of death and serious injury are around large signalised intersections. These are all large signalised intersections. So now there's an exposure element to that. You're getting a lot of vehicles through these spots, but they're also going through at high speeds because this is outer suburban. This is where the speeds are up a bit. And the angles of crashes are bad. So what do you then, started out by saying roundabout, and I love that. Can we do a roundabout? And I said the cost. The reason, the cost is so big is because of the area required for a roundabout. It's a big area required. And that's usually because the big, large vehicle needs to track around this area, this big swept path. So it needs a lot of space to be able to turn. And, if you wanted a big vehicle to be able to do a U-turn, it's got to be really big. And so it's a sort of example there. But we are going to get a huge advantage because we address the severity of crashes. We don't tend to, in a safe system assessment, say that a roundabout is going to reduce the likelihood of crashes, because we know that it's got some challenges associated with minor crashes, rear-end crashes. If it's a two-lane roundabout like you would have had to build back there, there's some side swipe issues, certainly. But the key is that they're happening at low speed. Little aside before I talk a little bit more about roundabouts. If you have unbalanced flow, so, if this one was 20,000 vehicles a day, well, it'd be two-lane, but anyway, that's okay. And this one's your minor road. What you can do to try to manage unbalanced flow with a roundabout is to meter it. And metering it is to put a set of traffic signals there. And what I like to do if I'm metering a roundabout is make it a pedestrian operated signal. But you put a loop down here that connects to these signals. And so when your traffic queues up, sets the loop, you get this signals to activate, stops them there, flushes them out, and then you open it up again and off they go. So you can meter a roundabout, start opening if you have unbalanced flow. It's also a really good thing to do as a roundabout gets saturated. So you can't get enough traffic through. If it's a traffic route and that's your sort of aim, the idea of ripping it out and putting signals there for traffic flow, well, you can start by metering legs to really extend its life. The size was a challenge with our budget. Could we go something little? This is obviously a very different road environment. But look at this little painted that. Okay, a little bit of cost maybe with these splitter islands, but generally a very low cost treatment there. How effective is that going to be? Well, interestingly, there's actually quite a big effect of something like this due to the fact that nobody approaching this believes they have ultimate priority. Everybody approaching it will slow down, look around. Now, yes, admittedly, some are going to straight line this and run it fast, but they will have had a look to see if they've got that ability to do that. So that's interesting. And if you're worried, about that straight line and the fast, you could put some features to slow vehicles down. Slightly, well, quite a different road environment, obviously, so it may not be, but I do like you to think about, can we get a roundabout in is a wonderful question to be asking, and not dismissing that straight away, because roundabouts have these wonderful features. Less conflict points. Conflict points being just a way you can crash. So this is passenger vehicle to passenger vehicle. I've not included pedestrian cyclists at this stage, but each dot there is just a way that you can crash. And you can see there at a signalised intersection, crossroad, there's a lot of conflict points. At a roundabout, not so many. The angle you crash at a roundabout, far better. Far better crash angles. And this one, my picture to say that when people approach an intersection, they do it in all states of consciousness. In fact, that's how people drive. Some of them are half asleep. Some of them are thinking about the argument they had with their partner. Some of them have worked a double shift and they're trying to drive to their brother's wedding. We don't want them driving in these states. But I'll tell you now, they are. They absolutely are. And interestingly, if you have a set of traffic signals, a portion of those will drive straight through the red. Just completely miss it. All right? And some of you have probably done that and just gone, I don't remember the last 2 minutes of driving at all. Some of you maybe have run red, not intentionally. So there's this element when you put something in the middle of the road, a roundabout, they wake up, they come back to reality, they look around, and you've just got these immediate big road safety wins. The roundabouts are just this wonderful, wonderful road safety treatment. Two-lane roundabouts start to lose some of that due to some straight lines, some higher speeds. And you can see this very sort of simple sort of demonstration of some research. Double-lane roundabouts in blue. This is roundabout radius, so bigger roundabout, smaller roundabout and the like, and speed through the roundabout, and speed being always a pretty good proxy for crashes at intersections. Not the only way to look at things, but you can see there that small radius double lane roundabouts don't perform too well at all, and they get better as you get them bigger. Single lane roundabouts perform pretty well, and turbo roundabouts, which are a double lane roundabout, performing pretty much as a single lane roundabout. Now I'll show you what a turbo is for interest, but also to show, people are really pushing to try to bring everything as safe as possible. So a turbo roundabout is simply a roundabout with a raised separator in the carriageway there and around. Now, I will give a prize for anybody who can tell me the line marking configuration of a roundabout like this. So we would line mark a roundabout similar to this anyway. This one actually just puts large separators in the circulating carriageway, concrete separators. In fact, there's a demonstration of it. So you've got that there. The way it's line marked has a specific name. That's a little bit of traffic engineering nerd trivia there. Adam has got it. It is Alberta line marking. Spiral line marking is a good description of it. That's more the generic term of it, but Alberta line marking is what I want. So special prize there, Kathy, please. Anyway, so a raised separator, which sort of channelizes your movement. So if you want to turn right, you get yourself in here and you sort of turn out there, and it stops people taking a straight line. What I love about this aerial image, look, we've got some conflict happening there. But look at the angle that conflict's happening. Wonderful, just beautiful stuff. We know if that crash happens, first of all, they're going to be going slow, aren't they? Slower. And if they did hit them, the angle is going to be favourable. Now you can get some pretty big turbo roundabouts. This is one out of the Netherlands. And what I loved about this one, well, it was fascinating. We had a Dutch engineer that we brought out to talk about actually cyclists and roundabouts was the specific topic we were trying to understand and delve into and look for new designs and the like. And I just happened to show the Dutch engineer this one. I said, this just boggles my mind. Like the land take of it is huge. The cost of it would be massive. And in Australia and New Zealand, we would inevitably either have gone to a grade separated facility, or we would just have a large signalized intersection with 3 lanes in each direction and big signals, and it'd be operating at fairly high speed. And the response from the Dutch engineer was, but what about all the death and serious injury in that sort of very Dutch very Dutch response? I'm like, yeah, I know, like that's exactly it. Like, and he just couldn't fathom that you would possibly operate a signalized intersection at those high speeds in that configuration. This slows the vehicles on the approach, alters the conflict angle. It also is signalized to control this, but not going to let the signalized intersection happen at high speed and bad conflict angles. That's just ludicrous. So I just put it out there to show a different mindset, just non-acceptance of death and serious injury if people make mistakes. Now, anybody who's follows Safe System Solutions on LinkedIn, and we posted about this last night, popped this out as an idea to industry, and it's just fun to read the comments coming in, because people are going berserk, like, this is the stupidest thing I've ever seen, and you can't possibly do it. And don't get me wrong, it's different. People don't like different. They get angry at different. But really just start considering different ways to operate large signalized intersections. We can't just say, maybe if we make all the lanterns LEDs, that'll stop the death and serious injury. We've tried that. Maybe if we, I don't know, put a red light camera, that'll stop the death and serious injury. No. We'll reduce by little bits the death and serious injury. We have a fundamental issue of speed and angle, and humans making mistakes. We need to start altering the speeds and the angles. And I think this one is a decent idea. Why is it like this and not just a roundabout? Because it's a capacity issue. So when you've got these major arterials, these sort of big traffic sewers, let's call them, you're trying to pump as many cars through as you possibly can, and a roundabout just cannot take that amount of vehicles. There's no arguing that. You can traffic model that every day, and you'll see that a roundabout cannot take what a set of traffic signals can take. And so you're trying to alter them to get some of the benefits still. So a vehicle approaching this is going to have to slow down, change their angle, wake up, and we've got wins already. Now, this is trying to cater for capacity with the cut-throughs. So I think we need to look at this stuff and, seriously take it on as ideas. Okay, there's going to be practical challenges. There's obviously pedestrians and cyclists to think about, but this is a big traffic sewer, as I keep saying, and our aim, or in this environment under its framework, is to move as much traffic through there as possible. But we need to do that safely. Now, it does remind me of something, and there's a little squircle. Is another similar thing, but I won't get into that. It does remind me of something. I'm actually going to stop sharing, and I'm going to jump out of and find something, Kathy, as you tell me if there's any questions or comments at this stage. I hope there is.
No, you just lost the whole audience to LinkedIn, so they can see the comments you just talked about. So you're okay. We'll just give everyone a minute to come back now.
I'm delving into my archives here because it does remind me of a little thing that I used to. Let me tell you a story. Hopefully, I have the time for this.
Yeah.
So I was in the.
Yeah. So, sorry. Go on. Yep.
Oh, do you have questions?
Yeah, there's a couple of questions that have come through. Let's just let's recap on roundabouts. Just to, if there are fewer conflict points, does that then not reduce likelihood and severity?
Yeah, it is a really good point. It certainly reduces the likelihood of those particular crash types. The reason we generally just attribute it to severity is due to the increase in rear end, particularly crashes, minor rear ends. Okay, and it's that sort of stop, start, stop, start, stop, start, because every individual is making those decisions as they go. They're very alert, but there's just this minor, minor crash increase. It's not. I didn't sort of dot point it there as a conflict point in the rear end. All the rear end conflict points on the way up and down. So that's the reason. But I can appreciate that lower likelihood commentary around the more simple movement. But signals also very simple in terms of green, go through, red, stop, from that perspective as well. So anyway.
Thank you. On those more complex roundabouts that you showed, do we consider older people because more complexity maybe equals more likelihood of a crash?
Yeah, you've got it. You do. Interesting, like cognitive abilities certainly decline, and there's actually a really good report that Bruce Corbin did, if anybody knows Bruce, which was older road user infrastructure for older road users, and how it what attributes of a road system are more challenging and result in safety issues for older road users in particular. Interestingly, roundabouts performed actually quite well, even compared to traffic signals, due to that severity outcome aspect. Yes, it's more challenging, but the severity of everything was much lower. But you're right, you'd need to factor some of that in. I personally think that those mock-ups that I was showing you there, if we put them on the ground, when you're actually in there and you've got signals and it's channelized areas, it's actually not going to be anywhere near as bad as people think. When you see it from the top, everybody freaks out. But you'd want to do some, modeling. You'd want to do some visual imagery of it, and you'd want to play it all out. But the principle of slowing people, improving angles, is so important.
Thank you, Ken. There's a comment here. There used to be a Highways Agency UK intersection layout called a sign about, which had deflection at approaches to signals to slow speeds with high capacity at stop lines with short burst green times. It was different to a signalised roundabout.
I love it. I love it. Yep. Anything to that, like the deflection on the approach, is just a acknowledgement that we can't run these intersections at these high speeds. So the story I was just going to tell, which I thought about, was so I was working at Vic Roads in the road safety department, and there was another congestion easing package by government. So, another $300 million to ease congestion or whatever it was. Outer suburban Melbourne was, clogged up and people are angry. And so, it just was basically a massive package of rip roundabouts out and replace with traffic signals, because we can move traffic better. And so my task was basically, they would submit the projects in, they would be handed over to myself for a technical review from the road safety department, and the signals ops people would review them as well. And they're handing them over to me, expecting a review of the line marking. Are we using the enough signal aspects and sight lines and any other issues like that. What I started producing was this this memo, and let me just bring it up because I've got I took the template when I left. I'm just going to share my screen here. So this is the memo I put on the top of their scope approval report and design. So it's from the Road Safety Department. Okay. So road safety state. The Road Safety Department has analysed this project as increasing crashes as follows. So project life, 20-year life on the project they were using. The number of deaths attributed to this project, 2.3. I put little people just to remind them. People. Number of serious injuries attributed to this project, 12.6. More people. Statement of acceptance. The above road trauma is accepted by, and then we'd send that back for the regional manager to sign, the regional director to sign. So this caused a lot of trouble, I'll say. But the reality was that nobody was actually arguing with this. Nobody was arguing that it would cause that amount of death and that amount of serious injury. I mean, that was pretty well established. We've got great tools and abilities to predict this sort of stuff. No worries. The executive director that hauled me into the office and was saying, managing a road system's complex, and we have to, balance a whole lot of competing demands, and there's really important advantages in moving people quicker, more time with their families, better for the economy, and all this sort of stuff. The reality is, if somebody's going to make a choice that's going to increase death and serious injury to our community, well, stand up and sign the damn page that's going to happen. Anyway, I never got one signed, of course, and I was told to stop putting these on the reports. I didn't get fired, by the way. But it did spark a lot more thinking around these intersections. That was I went off on a tangent.
You did. You didn't get fired, huh? Okay. Anyway, whatever. Just some more questions on the roundabout. The complex roundabouts, do they have less crashes? Has there been some data on that?
So these are artistic mock-ups. These have not been not actually been built. I put them out there so people will start thinking and talking and trying to come up with ways to reduce speed, to improve the angles while we still get the capacity through there. Exactly why we put it out on LinkedIn as well, to get that discussion happening and get people to question our large signalised intersections.
Nice. We've got a very keen eye for back to exposure, likelihood and severity. In the quiz that people did, reducing speeds reduces the likelihood of crashes. True. How come race safety platforms don't alter the likelihood of crashes, only the severity?
Yeah, that's a good question. So again, yeah.
Too clever, Ken.
I can completely see where that's coming from. The reason we've put this as severity, to be honest, is that Austroads has sort of determined that in the Safe System Assessment Framework. Did we actually have that as a specific quiz question?
Yes.
We may need to go and give some people some points, because I can see their point of view. Reduced speed is a good thing for both likelihood and severity. I'm going to take a note of that one. I'm going to come back. I'm going to have a look what Austroads actually said on that topic, because I think it's a good question. But let's talk about race safety platforms. And you're right, I've ticked them here as just a severity influencer. But Good point. So race safety platforms was actually what they ended up proposing at that intersection. Because they said, we wanted to do signals. All these things say signals, just like many of you concluded. You went, well, cost, and we go, unbalanced flow, and signalisation is the go. A lot of you were thinking race safety platforms as well, or raising the whole intersection, which, as I say, like 10 years ago, you would have been just laughed at. 5 years ago, you probably would have been laughed at. 20,000 vehicles a day. Heavy vehicle route, bus route, major artery. You don't do vertical deflection. You don't do anything raised. That's insane. I do have likelihood and severity ticked on this one, but the likelihood was more around the signals rather than but why have they just raised these bits and not the whole intersection? Well, why bother raising the whole intersection when they're only trying to hit up the bullet vehicle speed? The target vehicle speed doesn't need to be altered, does it? Going in, coming out. They're not the ones doing the damage. So you can save yourself some money. You don't need to disrupt the turn movement out. And you just put dampening speeds on the approach to that conflict point. Now, these are not like urban speed humps, and I'm sure some of you are very aware of them. They're a much shallower grade. These ones were targeting 50 kilometers an hour because that's that right angle threshold speed that we talked about. Go back to those tables, those graphs. 50 was about the threshold speed. Trying to get bullet vehicle speeds down to 50. Advisory. 50. I just love this picture. So I was out there reviewing it again, post-installation, and took this photo. I just love the fact that we've got green lights and we've got the vehicle approaching it and slowing down. Just through the conflict point, through the dangerous area. What a win. Actually, you also find that the race safety platform significantly reduces the dilemma zone. The dilemma zone is a point in time and space. It's a well-documented research thing where a driver is in a dilemma as to, do I put the foot down and go through, or do I brake? And I'm sure you've been in the dilemma zone many times. And the presence of that race safety platform just pulls most of them back to say, I'm going to stop. Your dilemma zone really shrinks. And it's wonderful to see New Zealand's getting on board the raised safety platforms at intersections, or raised intersections. Here's your one down in just outside Hamilton there, Gordonton something. Somebody write into the chat. Gordonton Thomas. So go out and have a look at it next time you're in Hamilton. And yeah, same thinking. Got to be signalised. Signals are the go here, but not going to accept those high speeds through that intersection. And it's really heartwarming to see now that at least when Vic Roads or the Victorian government rips out a roundabout, as they did here, Dalton and Childs, they supplement it with something to bring speeds down within tolerable levels. So this was a road, and it has got on the main road 52,000 vehicles a day. Not a small road. There's the minor road is still at 23,000 vehicles a day. This is a emergency vehicle route. It's a bus route. It's a heavy vehicle route. It's got everything. And vehicle speeds are slowed going through there to at least 50. I would like to see this much slower, probably down to a 20 on the slip lane, but that's okay. At least we're not ripping roundabouts in and putting traffic signals with no speed reduction devices as well. And so there's lots of info. There's a race safety platform design note. Austroads has just released a race safety platform document. Again, New Zealanders leading the way on that one. That one was Hamish Mackey and crew leading that project. Did a beautiful job collecting lots of intel on race safety platforms. So look out for that one if you're interested. was a bit more. Let me just touch back on roundabout. I just want to show you this example again. Crossroad, high speed, 200 km/h roads, arterial road sort of turns around there. They're looking at improving it. This thing is a telecommunication exchange building, and it's just going to cost an absolute bomb to move. Properties, they're looking roundabout. We want a roundabout here. Slow speeds, improved conflict angles. Everything's good, but the cost of it is just obscene now with this and that. And how do we do something here? And then they revert back to thinking, okay, well, we'll just go with a right turn lane. Maybe a RIOS, like a rural intersection activated warning sign or speed sign, so lower the speed when vehicles are approaching. All of these things are reducing the likelihood of crashes. We'll do lighting and everything like that, but you're still left with this fundamental challenge of a high-speed intersection and vehicles where people are making these choices or going to make mistakes. Anyway, for this one, they decided there's that something like $1.3 million to move the damn thing. It was insane. Let alone, buying the land and the like, and doing in reverse curves. If you wanted to do a roundabout, you probably got to do reverse curves on the approach to try to slow vehicles. The roundabout itself area would be huge. They said, well, what about that small roundabout? What about we do something little? How would that play out? They did it. Straight approaches. They're worried about speeds on the approach and the like, and worried about how the heavy vehicles could get around it. They did a few raised safety platforms on the approach, dampen the speed down, raise the intersection, a bit more design work. See the raised platforms there, designed for about a 40 in this case, and that Austra's document has some good ramp profile detail for different speeds that you're targeting. But they built this one as well, and you can see here a little bit of drone footage for you. Ramps on the approach, slow the vehicles down a bit. Building's still there, didn't have to touch that. And you can see it's a very tiny little roundabout in the middle there, and a large concrete apron for the vehicles to sweep around. So again, we've just had this big win because the vehicles are not going through there at speed. They're alert. They're looking around. If anything happens, it's going to be low speed, better conflict angle.
And Ken, what's the cost on that one?
Yeah, I think this was about $3 million in the end. And I think they had 5 million for a full size. So mind you, there was a lot of design risk management workshops and, lots of money to consultants to try to weed through this new innovative way to approach things. So I think we can probably do them cheaper. We've just finished writing up a road design note on compact roundabouts for the Victorian government, which they're going to release soon, hopefully. So to give you some intel information about some of the specifics, because there's a lot of little intricate design detail around these sorts of things. All right, quick little quiz time, Kathy, and then I better hurry up moving through some stuff.
Yes.
Yep. Got a quiz there?
Yeah, just a one question quiz. This one, true or false, traffic signals are not safe system? True, false, or unintelligible question? Interesting.
An intelligible question being, that doesn't make sense, Ken. What do you...
Now, just some questions that have come through. Some comments too. Back to roundabouts. French still have roundabouts with priority to people coming into the roundabout and priority to right turning traffic onto the main road you're on. These roundabouts shown are less confusing than that, in that opinion.
The French are like the world leader in roundabouts in terms of the amount they're producing. I've never driven a roundabout in France. Actually, no, I haven't. But anyway, they produce something like 500 roundabouts a year. They just go, we're going to make every intersection in France a roundabout.
On the road safety platform, would it be better comfort for bus passengers if the whole intersection is raised?
Potentially. Again, if you do this, look on the design specifics of them, you want to make the length of the table at least the length of your largest vehicle, so that they can fully come up and fully onto a platform and then fully go down.
Mm-hmm.
But if you do a longer area, you can taper it. You don't need to come down at the same angle. In fact, you don't come down at the same angle or the same grade as you go up. You can just very slowly taper it out.
And there was a question about the raised safety platform in the picture, and this was in that, artist's impression type one. Looked like a pancake. Will it not achieve the reduced speed for reduced severity? Yeah,
the construction challenges are certainly there. So again, have a look at the Austroads raised safety platform document, because they used some data from Victoria in terms of vertical acceleration of passenger vehicles and the like. You slow down on the approach to these things. It's not using the physical thing to slow you down. So you slow down on the approach just like you would to an urban speed hump. But you're right. If you don't get the grades right, people just start to realise that and then just go through normal speed anyway.
What is the crash record associated with high-speed signalised intersection where the bullet vehicles are going at 100 kilometres an hour?
Yeah, well, I mean, most jurisdictions don't allow it, but most jurisdictions have twigged onto the fact that is just that's just going to be really, really bad when things go wrong. So most jurisdictions have policies in place that you cannot do that. But occasionally they do appear, and they play out that the likelihood of crashes has been reduced, absolutely. But when they happen, oh my God, they are so bad. There's really not a huge amount of them out there. Right, let's have a look at the results of that little poll. Are we sharing that? We are sharing that. Traffic signals are not safe systems. So a few people said true, quite a few people said false, and a number of you said unintelligible question. Well, I would tend towards unintelligible question for a couple of reasons. Because first of all, the idea of safe system or not safe system, like, it's a spectrum. I mean, we don't like to use binary terms in safe system. So better aligned with safe system principles, not so well aligned with safe system principles. But the real one is here that you have no context. You're not given any context in this. Traffic signals in their own right are just traffic signals. When you place them in context in terms of speed, environment and the like, then you're able to start making some commentary around whether they align highly with safe system principles or do not align highly with safe system principles based on the speeds that crashes will happen and the angles that crashes will happen. But benefit of the doubt for those who said true or false, maybe you had a specific context in mind that you were thinking about. But one of the things I don't want you to come out of this course and say, oh, traffic signals are a not safe system and we should never do them, or the like. I mean, that's not what we're saying. It's about understand the context, the speeds, the angles, the way humans are going to operate and fail, and analyze that perspective. So thanks for doing that. Let's briefly talk about lane departure, and then I've got to introduce you to your little exercise to do. A road like this, and there are so many of them out there in New Zealand, I mean, just long, straight roads, or some long, windy roads, separated by a white line, sealed shoulders sometimes not sealed shoulders, hazards in the roadside, and we just see huge amounts of this and a high amount of death and serious injury. I don't need to tell you, but you're going to get head-on crashes and you're going to get run-off road crashes. And it's going to be people falling asleep, being distracted by something, leaving their lane, and we have these issues. We do it at a higher speed, and the results are horrific. So very common scenario in New Zealand here. You can see high speed, volume. Only thing we can hope is that people obey the lane that they are told to drive in. And unfortunately, we know that they won't. May not be intentional. We know that when they're hitting these poles or trees, the severity is going to be very high, considering the ANCAP crash test is at 32 kilometres an hour. The slide here says 29 because that's the one it's just gone up from. Here's a little bit of footage that I've shown some people before, which was predicted at 60 kilometres an hour, just to show you the violence of this crash type. So hopefully that's streamed through to you. That point source hazard is just hugely violent in terms of the amount of energy imparted into the vehicle. It's just scary. So removing those hazards is a really good thing to do, the point source hazards. But we do need to consider rollover as well. So removing all your hazards out of the roadside is will reduce risk significantly. But it's not going to eliminate it because we still have the rollover crashes to deal with. So as your object hits come down, as you create these cleared areas, clear zones, your rollovers will go up. That's because there's space for a vehicle to yaw, to recover, to then roll. And here you see run-off-road casualty crash risk per 100 million VKT, prize for the first person to write in what VKT stands for. And you see there that as you create clear zones or cleared areas, the number of crashes comes down, but then asymptotes out at around 4 casualty crashes per 100 million VKTs. Who was in first? David was in first with vehicle kilometres travelled. Lots of you got that, but just maybe David has the quickest internet. So, I mean, that's an interesting one. That you know, you can just keep creating clear zone, and you're not actually going to get to the elimination of death and serious injury from run-off road crashes. And it's because of that rollover, that yawing, that rollover impact. I've got lots of sort of slides on that, but wide clear zones are not necessarily a safe place to be. They're safer than point source hazards, obviously. But you've got to think about these vehicles and go well beyond anything you clear and the rollover crashes. And it's about the first 4 to 5 meters where you get your biggest bang for your buck in terms of clearing roadsides. And only a year ago, this is exactly how the Austroads Guide to Road Design Part 6 would tell you to design a roadside. A big shoulder, 110 kilometre per hour road this is. You've calculated your clear zone, you'd have your trees on at that point. Maybe you wouldn't have that one there, you'd have a big wide median. But we know there's a heap of death and serious injury on this road from people falling asleep, leaving the road, going out into these trees, going all the way to the other side of the road, hitting vehicles. I'm not going to go through, sorry, I'm going to move quickly through some of that. The new Austroads Guide to Road Design Part 6, and hopefully your slides have caught up by now. I've got a picture of that on the screen. It's got some new information. It's there's a lot in there, but it's worth having a look at. But in general, alignment with safe system principles for mid-block, high-speed roads, the best alignment is going to be continuous barrier, middle and outside. And then it sort of goes down from there. And I've put this into your notes. I mean, there's enough information and enough traction with this now. People are generally accepting of continuous barriers as a highly aligned safe system way of going. The details can be important. But you can see even like this cross section here, where you've got big wide median, you've got wide cleared areas. That only gets 4 stars. you put a barrier there and a barrier there and a barrier there, and you can narrow it all up, and you've got 5 stars and better alignment with safe system principles. So, you know, you don't even need to buy as much land now. There's a win. Lots of cross sections there. I'm going to jump through because I want to give you some info on your assignment. I talked about the specific detail of how you get your barrier system in, and there's a lot in that. I mean, we do a 3-day course on barrier design, which is similar to the one that's offered in New Zealand as well, because there's so much intricate detail around that, and we're not going to get into that. Offset being one of them. But I'll just end on this one to just talk about continually innovating. We need to continue to push. We need to continue to look for new things to manage energy. And that's the frontier of innovation in my mind in the space we're in, energy management, with the infrastructure. Our vehicle engineering colleagues have been onto this for ages. They're all crumple zones, airbags, seatbelts, all, severity management devices. Us infrastructure, we're lagging on that. Yeah, we've done some things in the past, but we need a lot more. This one's the example of what's called a raptor cushion. And it's just one example, I think, that is good in terms of energy management. Raptor cushions sit around power poles or trees, and they have a little bit of crumple to them, but that's not its real innovative management. I mean, you could just put a big cushion around it, really. But they act by rotating when struck. So as a vehicle leaves the road, hits it, it rotates and it sort of moves the vehicle along, so it washes its energy off over time. Sort of like they say, I think, in martial arts, where the punch, you deflect the energy of the punch. I don't do martial arts. I've never done martial arts, but that's what I see in movies. But so rotates, and I think that kind of innovation, that kind of thinking is really good. Here's an example of a raptor at play. A old vehicle, 4 male passengers, 2 in the morning, hit the thing at a predicted 93 kilometers an hour. And it rotated, it moved them along, enough to knock the power pole down as well, but they all survived, minor injuries, led a normal, healthy life. What time is it? Okay. Do we need a quiz if we've got one? No, we don't. Do we have one?
No, I think we might do some questions if that's okay, Ken, because there's a few questions that have come through.
Yeah.
Yeah, great. Do clear zones increase operating speeds?
Yeah, they can. I mean, the sort of perceptual countermeasure of narrowing lanes, putting objects close to the road is certainly there. It lowers operating speeds if you narrow things up, and so as you open them up, it will increase speed by a bit. So that, yeah, there's a little bit to that, but like the idea of putting hazards close to the road to slow vehicles is not a great idea.
Thank you. When we're talking about this as part of a system, is there movement in legislation in Australia or New Zealand that you know of with regards to electricity, etc., to put pressure on them to remove or reduce poles and other utility infrastructure?
It's such a great question and comment, because I have some major issues with utility providers in the sense that the preservation of their asset is just like they are blinkered only to that. And you see vehicles or crashes, people are killed on a power pole, knocks the power pole down, and the response can be but I've seen the response of some of the utility providers is, well, we'll build the damn pole stronger next time. So then a concrete sort of reinforced pole goes in the exact same spot. I think that we need to work with them. We did have a little bit of a chat with the Transport Accident Commission in Victoria about the possibility of suing utility providers for for some of the actions. They elected not to go down that track and more do the approach of trying to work with them, provide guidance, provide information on these sorts of things. Try to do that. I think suing them would do the job. Maybe a class action from seriously injured parties, from utility poles that have been installed in a time where we know the risks involved. But yeah, absolutely, it's a major issue. And even those Raptor cushions are an interesting one. They say a lot of people saying, utility providers saying, no, you can't put that on there because it impedes our ability to access for maintenance purposes or these sorts of things, which, you kind of think, well, you've got something here that presents a risk of death and serious injury to our road users, and you're not willing to budge because it's going to be a little bit more annoying to maintain. It just doesn't fly with me. But mind you, I have a completely blinkered safety view, maybe, people will argue. So.
Okay, some barrier questions. Why is a 1+1 with barriers road less safe than a 2+2 with barriers road?
Well, it all depends on volume, but I think there was a little sort of footnote on the side of that with some volume. There was an assumption of some volumes in some of that. You've got overtaking challenges, undertaking challenges. If your volumes are high and you're providing only the one lane in each direction, there's a lot of context to it to be played out within that. 1+1 is a very safe option as well.
Can you give us an answer in 30 seconds? Steel concrete barrier better than a wire rope barrier in a high-speed environment? Yes.
Wire rope barrier is generally the best option. The more flexible the barrier, the better for passenger vehicles. And we can talk a lot about that, which I won't do. But there are, of course, specific situations, and it's all about context, where a concrete barrier is the most appropriate and safest, and a steel barrier is the most appropriate and safest. So context, 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 and exactly 30-second answer, good luck. 30-day answer, I could run with, but I'm not going to.
Okay, so Ready to Learn Lee is also telling us there's some good examples of working with lines companies in Esperton, South Canterbury, removal of poles. So maybe get in touch with Ready to Learn Lee.
Awesome, thank you.
On that one, should we go to the assignment, Ken?
Let's do it. So now you're going to have a quiz to do at the end of this, but you're also going to have a very quick assignment to get you starting to think about safe system in infrastructure. So you're going to go into Moodle, you're going to look down there as Kathy is and go, where's module 2? Right, okay, module 2 assignment. Let's have a click on that. Okay, and there we go. I've got a Word document to work with, and my Word document downloads, and we open it up, and here it is, and it's got some instructions. That's good. Straight away onto instructions, and it says, first thing to do is select an intersection, any intersection. It could be outside your house, anyone you might have safety concerns with, could be one you saw on holiday, could be one that you did a random Google Street View and dropped it into the middle of South America and went, oh, there's an intersection. Up to you, anything you want. And then you're going to fill out the information that's highlighted below. We'll get to that in a second. You don't need to obviously inspect it if you're picking one in South America or anywhere like that. It's outside your window. Sure, you can look at it, but you can do it on Street View or the like. And then you're going to fill out factors in the table below. So you put your name. We also want a link to that intersection, be it a Street View link or just the coordinates of it, or just the the name of it. But go a bit further down, please, Kathy. This is what we want you to do. We want you to fill out exposure, factors that increase the exposure at that intersection. And you can do between 1 and 3. You can just put 1 there if you want, but you can put up to 3. Now, that is going to be things that are going to influence the numbers of vehicles, the numbers of pedestrians, the number of cyclists, number of motorcyclists going through. So it could be, the number of lanes on the approach. It could be the number of legs or the like. It could be the fact that it's, between a school and a train station, those sorts of factors. So that's what's influencing the exposure at this intersection. Then you go over to likelihood. You go, what's influencing the likelihood of crashes at this intersection? Okay, this is where you're looking at it. You're going, oh, sight lines could be an issue here. The speed of vehicles on the approach, or the surface doesn't look good. The line marking's not great. The signs are faded. There's a see-through effect here. All these factors influencing the likelihood of the crashes. Or maybe it's things like, all of that sort of likelihood stuff. Then we go over to severity. Okay, now we say severity. Crash is happening. What's influencing the severity of the crash at this intersection? The speed, the presence of heavy vehicles, the angles that people are going to crash at, the fact that, vulnerable road users or the like. So you put 1 to 3 factors in there. So you've analysed it, and then you go back and you go, right, okay, exposure. How could we change the exposure at this intersection? Maybe it's closing legs off. Maybe it's providing that overpass. Maybe it's, altering something to change the number of people, be that in vehicles or pedestrians or cyclists or motorcyclists, exposed to crashes at this intersection. You do the same then for likelihood. What could we alter to reduce the likelihood of crashes? Could we improve the lighting? Could we add features? Could we, whatever it is. And then the severity. Now you say, okay, what can we do to make sure when crashes happen, the severity is lower? Can we change the speeds? Can we alter the angles? Can we ban some particularly, dangerous vehicles that are going to be going with big mass and speed or whatever it is? That's it. Now, it shouldn't take you too long because you do it at the desk, quickly look at it, intersection, jot down a few points. I don't need long flowing explanations. It is really an assignment for you to prove that you understand exposure, likelihood, and severity. Okay? And you're going to submit that through Moodle by adding submission. PDF it if you can. You don't need to. It can be a Word document, but PDFing it is good. And you submit it. You drop your file in there, save changes, and I will mark them. And if you get them in before next session, I should have gone through a few of them by then, giving you some feedback, and we might delve into a few people's intersections to start next module and have a bit of a chat about exposure, likelihood, and severity.
There is
Good job,
also,
Kathy.
Thank you, Ken. There is also just a quick multiple choice quiz, whoopsies, as well, much like you did in the first session. And I'll add some other resources in there as well that you talked about in today's session. We've got the Austroads Raised Safety Platforms webinar, which I popped in there, but there's some others that you spoke about as well. So I'll add those in. Just so to alert people, the recordings after each webinar appear about a couple of hours afterwards. So I'll put today's recording in there, and I think we'll see you all on Wednesday. Any questions that have come through? No.
We're over time. Thank you.
Sorry. Thank you. Bye.